Hey, welcome back to Fat Mama Physics. In this video, we are going to talk about a specific and very unique form of a kind of a line that we may or may not have seen before. These are the horizontal and your vertical lines on your graph, not your x-axis and y-axis, but how to make these horizontal and vertical lines and what do they mean. And so, like I said, I would introduce a board game at the very beginning of the video that relates to that. So the game that we own, we bought this recently, and it's a roll and write, meaning you get a nice little, you get a pad that you get to record things on, and you want to score points by filling out as much as you can, and of course certain ways as best as you can. But here, let me show you that in a minute. Let me show you the box. So this game is called Cartographer. Put it sideways so you can see it. No, I'm just kidding. Okay, so Cartographer, if you know what the meaning of cartographer, it's like charting land. So it is it's a really good, it's a really nice roll and write game. So if you take a look at the map, which every player, this is a big pad, this is many different pages. Basically, if you play through all these pads, you kind of have to buy the game again, or you have to photocopy it because you use one every time you play for every player. So if you take a look at the map here, it's a nice looking grid, and you have spaces on there that show just blank space, and some of them have ruined spaces and mountains. So if you cover up mountain spaces, you get extra coins. If you cover up your ruined spaces, that may or may not be a good thing depending on the situation. And so how do you cover them up? They are dictated by these cards that tell you what to do. So for example, I have this card here. You can kind of see there's some symbols. There is a symbol for water, for farmland, and it tells you how big of a space you have to fill up. And it doesn't matter where you fill it up, but as long as you use that, you must use that shape to fill up your graph. So then you might be thinking, well, what's the purpose of this? Why do I have to do that? The idea is that you want to achieve certain goals. For example, the one that reminded me of this game is this particular goal. It has trees. You can see different kinds of trees there. So there are certain cards that tell you to draw trees and to what shape. Almost feels like what's that called? The Tetris. Almost feels like Tetris in a way, but it's more interesting than Tetris for sure. So what does this goal mean here? This say? It says here, earn 1 reputation star for each row and column with at least 1 forest space. The same forest space may be scored in a row and a column. So it kind of reminded me of these horizontal vertical lines that I had to cover up on my map in order for me to achieve all those points. And the funny thing about this game is there's these purple ones, that the events that turn up. So basically, when these guys turn up, this is called what is this? Kobold? It's some sort of monster card. Onslaught. So your opponent and you, it's an ambush card. So you and your opponent, whoever you're playing with, swap your map card, your roll and write sheet, and then they draw this ugly shape on your map, which then may screw up your plans in connecting things on your map and scoring a lot of points. So that's Cartographer. It seems very simple and might not seem as interesting as some of the other games I've shown us, but it's well designed. It's not designed to be it's not supposed to be a long game, but it definitely gets the idea of you kind of maximizing your land space and charting things out. It's quite fun, actually. Gotta give it a try. So that's my game for the day, so let me put this back. So let's begin what we're doing today. So how do we find these horizontal lines? How do we figure out these vertical lines? What do they do? So let's take a look at them. So here we have a vertical line. It is represented by an equation. And the equation is x plus a. Oh, sorry, x is equal to a. A is a constant. It is any number. And basically what that means is if x is equal to a, it does not matter what y is equal to. Because notice y is not even in the equation. So if x is equal to a, x is always equal to a, no matter what y is. So if I had to plot this out on this little sheet here, if y is this value, x is still going to be a. If y is this value, it's still going to be a. It's still going to be a. It's still going to be a. It's still going to be a, and it's going to cover up this entire vertical line. And notice that when you have that, this line intersects your x-axis at a. That right there is a. Okay, so that's what that means. So let's take a look at example 1a and see what that means. Okay, I'm going to treat every grid as one box. So this is 1, this is 2, and hey, not sure if you knew this, but if I go behind my y-axis line, then my x-axis become negative. And it's kind of like a number line. It increases the other direction. Now, if I had to plot x is equal to -4, it means it doesn't matter what y is equal to, 2, 3, 4, 5, whatever, my x is always going to be -4. So even if my y is 5, my x is still going to be -4. If my y is 4, my x is still going to be -4. If my y is -1, -2, -3, -4, it doesn't matter. I'm still going to get my x on the -4 line. Okay, so whatever that is, it's always going to be here. So so then I get this vertical line that goes through -4 on my x-axis, just like that. Okay. So that's what it means. My x is always equal to -4 regardless of y is equal to. So for all values of y, my x is equal to -4. Now, vice versa, I may have an equation that looks like this. Y is equal to a, and a can be any constant, any number. And in this case, it's the opposite. It means that regardless of what x is equal to, y is always going to be a. If x is equal to 3 or whatever this is, y is still going to be this a. Still going to be a, still going to be a, still going to be a, still going to be a value. And notice that this is going to intersect my y-axis at a. So let's take a look at an example, let's take a look at example C, okay? Okay, so notice this one here, it is not quite solved yet. So we kind of have to move the 2 to the other side by subtracting both sides by 2. I get y is equal to -2. And what that means is no matter what x is equal to, y is always equal to -2. So drawing this out, if I have x equal 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, okay, and I go negative below the y-axis line. So notice for x values, if I go behind the line, I become negative. For y values, if I go below the line, the x-axis line, then I become negative for my y values. Okay, so here I have y is equal to -2, meaning regardless of what x is equal to, y will be equal to -2. So if my x is 1, y is -2. If x is 4, my y is still -2. It is still -2, still -2, -2, always going to be -2 and continuously equal to -2. We might as well draw a line like this. And this is interesting because notice if I have y is equal to something, a constant, then I have now a horizontal line. My horizontal line is going to intersect my y-axis at where that number is. So if my y is -2, I have a horizontal line that's going to intersect my y-axis at -2. So here below we have a few examples. I'm just going to fill out some of these describing the graph. So for example 1a, my graph is a vertical line that intersects the x-axis at -4. And then for example 1c, I have a horizontal line where it intersects my y-axis at -2. Alright, so then I think we want to do the same thing for some of the other graphs, but let me do B first before I let you run off and try the rest, okay? So notice B, I have a coefficient by the x. Now, remember we always want to isolate for the variable, so we want to do that by dividing both sides by 2. I then get x is equal to 5 divided by 2, okay? As a number, that is 2.5. Okay, and of course, you can have constant values that are decimals. That's fine as fractions. Well, sure, why not? So that's just saying that no matter my value for y, my x will always be 2.5. So let's label my graph here. Okay, so then I have x is equal to 2.5. That's going to be somewhere here in between the two lines on the side. Okay, so that just means my value of x will always be 2.5 no matter what my y is. So I'm going to get a vertical line, and this vertical line is going to intersect my x-axis at 2.5. Okay, so there's the example where, yes, it is I have a vertical line, it intersects my x-axis at 2.5. Okay, so that was B. Okay, so notice below we have a couple of examples, which I think now you have the tools to try yourself. So I'm going to give you a chance to do D, E, F, and then afterwards I will fly through these examples. Good time to pause the video. Okay, so let's do this one. I have y is equal to -3, so 1, 2, 3, -3 is right here. And I'm going to label all of these, assuming... And here I have my y is equal to -3, which always going to be -3 no matter what my x value is going to be. So I have a line, I have a horizontal line that intersects my y-axis at -3. Okay, so next one is I have 4y equals to 2. We have to isolate for the y by dividing both sides by the 5. I get y is equal to 2 over 5, or in decimal form, this is 0.4. Okay, drawing my axes out. You could go by 1, or you can go up by, because that divides this equally into 5 pieces. Okay, so here my y is equal to 0.4 and will always equal to 0.4 no matter the situation, no matter what x is equal to. So I get a horizontal line that intersects my y-axis at 0.4. And last but not least, here we have x, 5 minus x is equal to 0. We can't have that. We need x and 5 on opposite sides of the equation. So I'm actually going to move x over by adding x to both sides of my equation. I get x is equal to 5 if I kind of flip it around like that. So then my graph is kind of going to look like this, in which no matter my value for y, my x will always be equal to 5. So here I'm going to get a vertical line through my x-axis at 5. So I get a vertical line that intersects my x-axis at 5. Okay, so there you go. There is F. Okay, zooming out. Okay, so let's take a look at what we have here. Just a general overview. If I have x is equal to something, I'm going to get a vertical line. If I have y equals something, I'm going to get a horizontal line. My vertical line is going to intersect my x-axis somewhere. My horizontal line is going to intersect my y-axis somewhere. And this gets useful later on when we deal with certain relationships, or it just means that no matter what, I'm always going to have that value. Let's give you an actual context very quickly. So let's say I have I'm looking at the relationship between time and distance. Let's say I'm looking at the relationship between time and how far I am away from my house. So in that case, if my time can keep going, but I may always be at my house, say the weekend, Thanksgiving or something, you're just stationary at your house. You're not moving anywhere. In that case, you're going to be, time can be anything. Your y value is always going to be 0. Oh, that's interesting. If y is going to be 0, which is your distance away from your house, you're going to have a straight line across the x-axis where you intersect the y-axis at 0, 0 because you're 0 meters away from your house. grabbing from a previous example from the last lesson. So that's a good example of where you might have something that intersects these lines, is that as time goes on, I am 0 meters away from my house. I'm going to get a flat line that's going to intersect at 0, 0 on my y-axis, not going anywhere from my house. Have a happy Thanksgiving, or happy times at home. I don't know what that will be. I wish you good luck with the rest of your practices, and I will see you next time back here for the next part, 5.3 part 2. Thank you for watching. Fat Mama Physics signing out.